Welcome to Year 1, Pure 1, Chapter 12.8, where we continue about looking at differentiation. And this time we'll look at second order derivatives. So, it's quite a simple chapter. When you differentiate this function, simple lessons are rather chapter. When you differentiate the function once, it is known as the first derivative. So anything you've done previously is called the first derivative. Okay. When you differentiate a second time, it's known as a second derivative. That's what it means. Okay, so for example, we have original function here. For example, y equals x to the power 4. Now you see in here, I'm just showing you different kind of notations, how we write first derivative and second derivative, okay, using the same function, x to the power 4. But one is written as y, one is written as f dash x. So there are different ways you can write this, okay? They're all equivalent. So when you differentiate the first time, you get 4x cubed. You can either write dy by dx or it's y dash, okay? They're both equivalent. Or if you use f of x, we use f dash x. When you differentiate second time, so differentiate, okay, 4x cubed, okay, differentiate again. 3 times 4 is 12, power minus 1, 12x squared. Then second derivative is d squared y over dx squared, which is 12x squared. And the y dash, this time you can see 2 dashes, means second derivative, 12x squared. So f, again, 2 dashes, f dash x equals 12x squared. We tend to write d squared over dx squared. That would be the sort of the easiest way to write to represent a number. What you can imagine, if you do a third, fourth, fifth derivative, the numbers get a bit more. There are more dashes, which is very difficult to read to count it. So right. So obviously, I want to explain what it means. Okay, by first derivative and second derivative. What's the meaning behind it? So first derivative. Okay, so first derivative. Okay, is the gradient function. So we talked about this before. Okay, the first derivative helps you work out the gradient function. So it describes, okay, it describes the rate of change of y over x. What about second derivative? The second derivative describes the rate of change. It's still a derivative, so we still talk about rate of change, okay, of the gradient function. I know it sounds a bit, abstract what we're talking about. The rate of change means how fast. So when we talk about the rate of change, rate of range, rate of change, sorry, rate of change, rate of range, rate of change. Okay. So when we talk about rate of change means y over x means how fast y is increasing over x. Okay. So for example, okay, if x is increasing 1 each time, okay, 1 per second, for example, use second as a unit. If x is increasing 1 by every second, so it goes 1, 2, 3, 4, but y is increasing 5 times, okay, 5 steps every seconds, okay, then the rate of change will be 5 over 1 because y is increasing by 5 where x is increasing by 1. So 5 over 1. All right, so basically the derivative dy by dx equals 5, or you can see the gradient equals 5. Whereas second derivative is less easy to see. What we'll talk about in here is we'll talk about how fast the gradient changes over time. So when we talk about, let's say a curve, okay, let's say a curve in here, okay, the gradient you can see is decreasing, right? So the gradient is actually in this case actually increasing because it's going from very negative to less negative. You can see it's less steep on the negative side. So we look at how fast the gradient changes over time. But we'll look into a bit more practically later. So example, let's talk about the real maths, the calculation of the first and second derivative. So find, okay, given that y equals 3x to the power 5 plus 4 of x squared. Oh, that's a comma, by the way, that's a comma. Find dy by dx. So let's differentiate. To differentiate, I'll probably rewrite y, the 4 of x squared into 4x to the power minus 2. Now I can do differentiation. Let's differentiate. 5 times 3 is 15. Power goes down by 1. Minus 2 times 4, minus 8. Power goes down by 1, minus 3. Easy peasy. Second derivative, similar, easy peasy. Okay. Just differentiate again. Differentiate the first derivative. 15 times 4, 60. Power goes down by 1 is 3. Minus 3 times 8, positive 24. Minus 3 minus 1, minus 4 in the power. Yeah, that's it. Okay. If you're happy with this, pause the video. Okay. Have a go at the question. Okay. Both question 1 and 2. Okay. When you're ready for the answer, you can press play. I realized I shouldn't show you all the answer for question 1 and 2 first. So here's the answer for question 1, okay, just in case. I think if there's one tricky part for this question, will be writing 1 over 2 root x as a half x to the power of minus a half. Okay, so here's the answer, but I'm going to show you the answer to question 2 very quickly. If you got it wrong, okay, it's not, you know, use this time to correct the answer for question 2. Okay, here's the answer for question 2. Okay, again, the tricky part I think probably is the beginning part where you have to simplify the algebra a little bit. So x over what I've done is I wrote root x as x to the power of a half, and then I separate the coefficient. So it's a third as a coefficient, and then the x over x to the power of a half. And then when you simplify, think about x to the power of 1 minus x to the power of a half, you get x to the power of a half. Okay. And then you can differentiate. So a half minus 1 is minus a half. So when you multiply, don't forget to change the sign. And yeah. Okay. Right. Anything else? No, I think that's the end of the lesson. Okay. That's the end of the lesson. Bye bye.